So, today's session starts with factorization. Factorization is somehow related to division. But first, let's make this statement. Let's say you have if you were given this expression, then you can go ahead and distribute 3x squared everything inside the parentheses. So 3x times 4x is 12x squared, and 3x times 5 is 15x. So 12x squared plus 15x is a product of 3x times 4x plus 5. Now let's do the reverse, meaning what? Let's find the greatest common factor between 12 and 15. The greatest common factor between 12 and 15 is 3. And the greatest common factor between x squared and x is x. Then I open the parentheses. So 12 divided by 3 is 4, x squared divided by x is x, and 15 divided by 3 is 5, and you end up with the original equation. This is what we mean by factorization. Okay, this is the product, this is it's factorization. One thing that you need to know is whatever you factor, the one inside the parentheses cannot be factored anymore, meaning what? It has to be prime. Prime numbers or prime expressions have factors only their own numbers in one. So that's what we mean by prime. Okay? So let's start with doing the greatest common factor. Greatest common factor. So I'm going to throw some examples in there. Let's see what we can do. Suppose you have 8x plus 12 and you are asked to find the greatest common factor. Then go ahead and find the factor of 8 and 12. And if you go ahead and do that, then you can see 4 is the greatest common factor of 8x and 12. The greatest common factor between x and 1, it is 1. So we cannot factor out x because there is no x in here. So you open the parentheses, 8 divided by 4 is 2, 2x, 12 divided by 4 is 3. Look at 2x plus 3. They have nothing in common that we can factor for. So your answer stays where it is. Okay. Let me see another one. 56m plus 35. Mind you, now there are two variables, right? So let's go ahead between 56 and 35. If you calculate the greatest common factor, you would end up with 7. And open a parenthesis, 56 divided by 7 is 8m, 35 divided by 7 is 5p. Look at the expressions inside the parenthesis. They have nothing in common, meaning what? They are prime. So we need, that's what we mean by greatest common factor. Okay? Let me do probably one or two more because it's not a difficult concept here. (9x squared) plus 12x cubed. Okay. So once again, find the greatest common factor between 9 and 12. You would have 3. Find the greatest common factor between x squared and x cubed. It is x squared, so you always take the one with the lowest degree. Once you open the parentheses, 9 divided by 3 gives you 3, and 12 divided by 3 gives you 4. X cubed divided by x squared gives you x, so you end up with 3 plus 4x, and that you can see it is prime. Let me do another one. 32p to the fourth minus 24p to the third plus 40p to the fifth. Again, the idea is finding the greatest common factor. So let's go ahead and try to find the greatest common factor between 32, 24, and 8. And 40, you would find out it is 8. Right? Between p to the fourth, p to the third, and p to the 5, always take the one with the lowest degree. P to the third is the greatest common factor. Once you do that, then it's precisely, it works out. 32 divided by 8 is 4. P to the 4 divided by p to the third is p. 24 divided by 8 is 3. P to the third, p to the third, it cancels out. Plus 40 divided by 8 is 5. And p to the 5 divided p to the third is p to the second. Once again, look, the expressions inside the parentheses have nothing in common. 4p minus 3 plus 5p squared. Okay. Take care of that. Let me do another one and then we're going to go to the next topic. X squared, y cubed. Now we have two variables. That's 30y to the fifth. 30y to the fifth. Minus 50x to the fourth, y to the seventh. And then let's find the greatest common factor of each, one at a time. Between 25, 30, and 15, you would have 5. Between x squared, nothing, and x to the 4, you have nothing. There is no x. So there is no x which can be used as the greatest common factor because the middle term has no x. Between y cubed, y to the fifth, and y to the seventh, y cubed is your greatest common factor. So the greatest common factor for the entire expression is 5y cubed. And let's open the parentheses. Now 25 divided by 5 is 5. I'm going to bring my x squared. Y cubed and y cubed, they cancel out. Then 30 divided by 5 is 6. Y to the fifth and y to the third, you have y to the second. 15 divided by 5 is 3. We have to bring x to the fourth here, and y to the seventh divided by y to the third is y to the fourth. And once again, we can justify this is the factored version of this one because these three expressions have nothing in common. They are prime. Okay? So that takes care of our discussion of greatest common factor. Now let's expand our thinking by talking about another concept, factoring by grouping. Okay. Factoring by grouping. So let's say factoring by grouping is ax, let's say minus ay plus bx minus by. In factoring by grouping, make sure that all your terms, there are 4 terms. Okay? If there are 5 terms or 3 terms, then it's not conceivable that we are doing factoring by grouping. So let's group this one and see what happens. Now find the greatest common factor between ax and ay, which is a. And then open the parentheses, so you would have x minus y. And then do the same thing for the second binomial. Common factor between bx and by is b. And then you have x minus y. Now, the next step is how to write it. X minus y is popping out twice of both of them. So meaning what? That is their greatest common factor, x minus y. Right? Once you take x minus y out as your factor, what is left is what? The ones in the boundary a plus b. So if I factor ax minus ay plus bx minus by, I end up with a plus b and x minus y. We can prove this. Let's go ahead and do the FOIL. So this is the reverse of FOIL. Go ahead, a times x is ax, a times ay is minus ay, b times x is bx, b times negative y is minus by. So you end up with our original equation. So this is an example of factoring by grouping. So if you have 4 terms, okay? Alright. So let's do some exercises of this. Suppose you have 6ax plus 12bx plus a plus 2b. So again, let's go ahead and do the grouping and find the greatest common factor between 6 and 12, which is 6. Between ax and bx is x, right? So what is left is what? It is a plus 2b, right? Now, bring the plus sign. Now you have to be careful. What is the greatest common factor between a and 2b? Some people say none. No, it's not true. The greatest common factor between a and 2b is 1. So I'm going to write 1 in here. And then I'm going to open a plus 2b. Now, I know I have done correctly factoring by grouping because I have what? A plus 2b and a plus 2b popping out twice. This is one of my factors. So I'm going to write a plus 2b. Once I take that as one my factor, then I have what? 6x and 1 at the boundary. That is my other factor, other binomial factors. A plus 2b times 6x plus 1. Again, you can go ahead and do the FOIL. You would end up with our original problem. Okay. Now, you have to be careful when you do factoring by grouping. So most of the times it's a trial and error to get the correct answer. So let's look at this one. P squared, Q squared, minus 10, minus 2Q squared, plus 5p squared. Now, if you go ahead and do the grouping as it is, you are not going to go anywhere. Look, if you do this, p squared, q squared, and 10, they have nothing in common. 2q squared plus 5p squared, they have nothing in common. You're going to get stuck. So you have to rearrange the order. Okay, again, this is a trial and error. It's not carved in the stone, so you have to really find a wiggle or a place where you can rearrange the terms. So do p squared q squared. I can do this 2q squared plus 5p squared minus 10. This is one way of rewriting it. And let's see whether I can factor this. Let's group this. Go ahead and try to find the greatest common factor between p squared, q squared, and 2q squared is q squared. Right? And then if you open the parentheses, so you end up with p squared minus 2. If you get another p squared minus 2 on this one, then that means you have factored it correctly. So between 5p squared and 10, your greatest common factor is 5. And if you take 5 out, you end up with p squared minus 2. Now I know we have factored the two binomials. So we have what? P squared minus 2 is one of them, and q squared plus 5 is another of them. And we're done. Okay? Okay. Let's see whether we can do another one. Okay. So there is another instance also that I really want to talk to you now. 10. Let's do this. 10ax minus 5ay plus 10bx x minus 5by. Okay. Look, now again this is 4 terms, but we can do something here. Look, I have 10, 5, 10, 5. There is something that is common for all 4 of them, which is 5. So that would be what? Your greatest common factor. So you take 5 out. And let's see what you end up with before you group them. Okay, so this would be 2ax minus ay plus 2bx minus by. Okay. Now let's group them. So let's leave 5 now, for now. But when we write the final expression, we will bring it down. So you have what? 2ax minus ay, and then plus 2bx minus by. Let's go ahead. Let's find the common factor between 2ax and ay. It is a. And what is left is 2x minus y. Do the same thing for 2bx and by. You have b, and then 2x minus 1. So your factors would be a plus b, and then 2x minus y. But don't forget 5, and you are done. Meaning what? If you FOIL this and multiply it by 5, then you're going to end up with our original expression. So one more item before we close this session. Which I forgot to mention when we do the greatest common factor. You could end up you can see this x minus 5 times x plus 6 plus x minus 5 and 2x plus 5. And you are asked to find the greatest common factor. The greatest common factor is x minus 5 because x minus 5 is popping out in both expressions. So do that, x minus 5, that is your common factor. But what is left? X plus 6 plus 2x plus 5. Right? Once you take once you take x minus 5 and x minus 5, you can see it clearly. Now this is x minus 5. Then go ahead, because this is addition, x plus 2x would give us what? 3x, and 6 plus 5 gives us 11. Okay? So the other way of saying x minus 5 times x plus 6 plus x minus 5 to x plus 5, when we factor them, it becomes x minus 5 times 3x plus 11. Okay? So that takes care of the greatest common factor and factoring by grouping. So our next section will be factoring trinomials.